Yeah. Kavika. It was just what it was. Okay, so let's first off just remember some rules. Okay? What happens when I take, if I have a to the n times a to the m, gentlemen, what do I do if they're like bases? What do I get to do with their exponent? Anybody remember from back in the day? We add them. I think somebody said that as well over there. So this would be a to the m plus n. So in our case, if I had like x cubed times x to the second would be, no ma'am, it is not. A to the fifth, because I would add them, right? Once again, when I multiply, I add the exponents. 7-1, talking, we're going to get actually into rational exponents, but I just want to make sure you guys understand exponents in general, remembering what they are, the rules of them. What happens if I divide exponents? We subtract them, correct? So here's an example. Right? What if I flip-flopped him? What's that? X to the -4th. But do I ever want negative exponent? So think about it. How many more? Where's there more? Top or bottom? Isn't there more x's on the bottom than the top? Right? That makes sense. So shouldn't I have more x's on the bottom than the top? So here's my little saying. If I ever have a negative exponent, I jump the line and change its sign. What if he was downstairs? Where would he go? Upstairs, right? So if he was like this, what would he be? A to the m. Okay. We have one more rule. Does anybody remember that last rule? What's the other one that we have? Power to a power. Which would be, what do we do on power to a power? Multiply, because once again, isn't something raised to a power that many times, right? And then after I multiply that many times, I just would continue to add the same amount over and over, which is what's repeated addition, multiplication, right? Okay, so those are the basic rules that we just need to make sure you guys are aware of, right? When we do so. But that's really not what we're learning today. The thing that we're learning today is rational exponents. So this right now is currently a radical. Okay? It's the nth root of a to the m. Nth root of a to the m. So this represents a m over n. So that also gives you kind of a reason why a square root works. What is the square root of 9, everybody? 3, we all know that's 3, right? Now let's show you a little bit better. Okay, remember, 9 is 3 squared, correct? You guys agree that's the same thing? What's here even though it's not there? Because it's a square root. Actually, it'd be 2 there, right? Does that make sense to everybody? So it does explain why it does become 3, because, once again, this is my m, this is my n. Right? Everybody there with me? which becomes 3 over 2 over 2, which is 3 to the first, which is 3. That's the reason why it works. Okay? So, we could simplify some items, such as, what is the 5th root of z to the 9th? Okay. A square root means it was looking for groups of 2, correct? What does a 5th root mean? Looking for groups of 5. How are you today? You're good, huh? All right, Sandra. You need to go visit the Pickering. So fun. Good. So, how many groups of 5 are in 9? 1, right? But how many are left over still in there? 4 of those. Because if I really brought this down, that's, oh my goodness, I'm struggling. V, 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 right? Okay, so notice there's my group of 5. That's why he got to come out, right? And then what's left over? 4 then. So really, isn't this division? How many times can 5 go into 9? 1 with 4 remainder. That's why the 4 remainder stays in. Does that make sense to everybody? Mark, you okay? Oh. Okay, so let's do that. Let's just write it. So let's say the 5th root of z to the 11th or something. Okay, what would it be, do you think? Has 2 groups, so I'd come z squared, and what's left over? 1, so it'd be the 5th root of, good question. Okay. Yes, Brady? Z squared, and then the 5th root of z, because how many times could 5 go into 11? Twice with 1 root. Make sense? Okay. Now, the thing that we also have to think about is I'm not sure which section. Well, you guys are lucky on the first one. So let's just quickly go through some items. Hopefully, do you guys all know your perfect squareds all the way up to your 20 perfect squareds? All right, let's go through. What's 1 squared? These are perfect squared. So we have 1, 4, 9, 16, 25, 36, 49, 64, 81, 100, 121, 144, that's where most of you stop, right? Okay, but it's 169, that's 13. 196 is 14. 225 is 15. 16 I always forget. Is that 256? Somebody really quick? I think it's 256. 256. 289 is 17. 324 is 18. 19 gets me to 19. Which one's 19? 19 times 19. 361? Yeah. Took me a while. And 400. Those are your perfect squares. You kind of have those. It's just so that you can do it quicker. Do you have to know all those? Why? Because I could break them down, couldn't I? Does that make sense to everybody? Except 361 is hard to know unless you know it. Because what does it break down to be? 19 and 19. Those are prime. It's kind of hard not to pull those out, right? Does that make sense to everybody? How about the cubes? I really don't go too far with my cubes, but what are my cubes? 1, 8, 27, 64, 125. That's usually about as high as I go with my cube. Okay. Fourths, how about fourths? 1, 16, 81, 256. Those are about as far as I go on my fourth. Okay, but why just knowing these, it just helps you be quicker, doesn't it? Right? You have to know, but it does help you become quicker at doing these items. Okay? So, ladies and gentlemen, let's try a hard one. Okay? What is 27 raised to the 2/3? Without using a machine, how could I find that out? So first off, we could rewrite this, because sometimes right now you might not feel comfortable. Do you guys agree with that? Agreed? Okay, what would I rewrite this as? How could I put this, right now it says a rational exponent, right? The cube root of 27 squared. Or I could even write the cube root of 27 times the cube root of 27, because that's being itself twice, right? Does anybody know what the perfect cube of 27 is? 3, so this is 3 times 3, which is, let me show you how I would look at this. Ladies and gentlemen, when you see a fraction as your exponent, this represents your root, correct? This is what I would say to myself. I say that is the cube root of 27. What is the cube root of 27? 3. So this is 3 squared, which is 9. That's how I look at those. Can a square root or any even root ever be negative to make it a real solution? We could have negatives and have imaginary solutions, right? But for real solutions, they always have to be positive, don't they? Okay. Can an odd root be negative? What is the cube root of negative 27? Negative 3. And that works because negative 3 times negative 3 times negative 3 is negative 27, right? Does that make sense how it can be a negative with a cube or an odd root? Yes, yes, yes? Okay. Should we practice some of these? Okay, I'm going to write down a few of them, and then I'll let you guys just practice. Okay? And once again, I personally always look at the radical first. Okay? So I look at this, this is a square root, correct? Square root of 25. 5, thank you. So this is 5 cubed, which is 120. Does it also understand why I went over that list of perfect cubes and perfect squares and stuff? So you can quickly look at them and look for those numbers. What is this saying? Cube root of 64. What is the cube root of 64? 4. Which is 16. Now notice, ladies and gentlemen, I don't know what 64 times 64 is. I don't. It's 3600, 400, and yeah, I don't want to do it like that. 1080 plus 16, 1096. Is that what it is? 64 squared. Was it? Somebody? 64 squared. Oh, I said 1,000, 4,000 where I was thinking. Okay. Watch what I could do here still. Notice I did 64 squared. Okay, what's in here at least, ladies and gentlemen? And evens, what's in here at least? 2. What's in that one at least? Then I might get here and say, oh, that's 8 times 7, just to make it a little quicker, which is 2 times 4, which is 2 times 2, right? So this was a cube root, correct? So what are we looking for? Groups of 3. 1, 2, 3. 1, 2, 3. 1, 2, 3. Oh, how did I mess that up? Is that really? Oh, it's 9. This is 64, you think, Barry? But we'll get there. Hold on. Still a 2 there. 64, which is 8 and 8. 2 and 4. 2 and 2. 2 and 4. 2 and 2. Group of 3. Group of 3. Group of 3. Group of 3. So how many groups of 3 do I have? 4. So that's 2 to the 4th, which is 16. It takes longer. Okay? Could I do it that way, though, if you needed to? Sure. But what I'm trying to say is if you know these perfect cube roots, perfect fifth roots, and things like that, you can make it a lot quicker. It does. So like right here, does this one even work? Yes. This one works. Because what does this say? Anybody tell me? This is 9 raised to this power, then timesing by a negative. What does this one say? This is -9 being raised to that power. You guys see the difference with what a parenthesis can mean? Once again, this is saying -1 times 9 to the 5 halves. Can I actually do that? What's the square root of 9? 3. 3 to the 5th. 81, 243, I think. Okay? So this is 243. -243. But on this one, can I have a square root of a negative number? So this one does not work. No, I don't know how we want to say that. Not possible. We say that not possible. Because once again, it's taking a square root of a negative number, right? Yes, if we wanted to talk about ice. We're not. Have I officially taught that to you here in this class? So we're not there yet. Does that make sense? But yes, and I could do it. Okay. How about this one? This is a cube root of a negative. Is a cube root of a negative okay? It is, right? What's the cube root of -8? -2. Then I raise that to the 4th. -2, -2, -2, -2. So that's 4 times 4, which is 16. Okay? Y'all see how we can do that? Okay. Now that might look crazy now, but you can really times those out if you want. But if you look at these and see that they're perfect, it helps you. Because then you're not squaring big numbers, right? Get nasty 4,096. Okay? What if I gave you this? How can I write that as a rational exponent? So once again, this is called a radical. How can I write this as a rational exponent? So once again, that's meaning I could raise it to a power. All right, say it again. Somebody was saying something. I just didn't hear you. Go ahead, Jamie.
I was saying 2x
Okay, that's close. I would say if that was worth 6 points, I might give you 5 or 4. Okay, but what's the power on 2 even though he doesn't have it right now? You got to treat him by himself, right? So this would be, now say it, Jamie. And the reason why I can do that, ladies and gentlemen, is that I can break it apart. This is the same thing as the 5th root of 2 times the 5th root of x cubed times the 5th root of y to the 4th. See how I just separate it? Does that make sense? How that works? And that's why it becomes 2 to the 1/5, x to the 3/5, y to the 4th. Because I'm separating them individually. Okay? A lot of people struggle when the 2 is connected to the x. Now, the way Jamie said it, okay, the way Jamie said it originally was the 5th root of 2x cubed y to the 4th. You said the answer was 2x raised to the 3/5 y to the 4th. What would need to happen up in our radical for this to happen? It would need parentheses around it. You guys see the difference between the two problems? This one is saying, right now, 2x is being cubed. Does everybody see that? Whereas the other problem is saying 2 is being raised to the first and x is being cubed, right? Don't get them confused with it, that they're both being raised to the power unless they are both in parentheses. Okay? Ori, not Ori, that sounded bad. You got chicken soup yet? I don't know. You went dressed as a damn chicken for a day. Is there any more rituals that have to happen? Are you keep going?
I don't know.
Oh, from the sexist part. Okay.
All on video.
All right. The chickens are sexist, people. Just to give a heads up. Is it really embarrassing? Oh, who's gonna really watch it? 3 people? Let's be honest. Then they have to listen to a whole math video to find it, though. Oh, that's torture itself, right? We should tell them. There you go. There you go. Okay, what is this going to be? Let's go step by step here. What would this represent? You know? Yeah? So first off, what happens when I ever have a negative exponent? What can I do? Jump the line! Change the sign! Like an anthem almost, guys. Abby's like, why did I come back? You're saying it, aren't you? But then, now that's just peaches right there, ladies and gentlemen, because what is 36 to the 1/2? That's just saying the square root of 36, isn't it? Which is what? Okay? All right, that was 7-1. You guys feel good about 7-1? Pretty simple, huh? Okay, 7-2, which is more of what I already gave you the rules of at the very beginning. I thought they were reminder rules, but they're rules in general. Okay, so here's our example. If I start you with 27 to the half times 27 to the 5/6, what is that similar to? Are they like bases? So what do we do if they're like bases? What do we do to their exponents? It was in your notes at the very beginning. We add them. So this would be 27 1/2 plus 5/6. Does everybody know the rules of adding fractions? Common denominator. Think of Arnold. I do every time. I see him and say, hasta la vista. No? You guys ever watch Terminator?
No.
It's an old show, so I can understand. This is 3/6. Does everybody understand how I got 3/6 from a half? So what is this equivalent to? 27 to the 8/6, which we don't like 8/6, do we? Right? Which is what? 4/3, which is 81. How did I get 81? Anybody help me? What did you say, Ben? Cube root 27 is 3. So now I'm at 3 to the 4th, which is 81. Right? Decatur, what's the Muse band? Is it a good band? Do you like the band? Have you seen the band? I went to Warped Tour this year. I didn't actually go, but I was parking cars. I had to go visit my pastor the next day. It was actually better, but I'm telling you. Okay. Did you like that? I'll shut up. All right, should we do another one? What do we do when we divide things that have like bases, Connor? Subtract. So what's 6/5 minus 8/5? -2/5. Does everybody agree with Connor? I agree with Connor, so I'm going to write it even if you didn't agree. Walker, you doing good, brother? Yep, he is. Do I like negative exponents? Where is he going to go? Downstairs. Do you know what 32 to the 2/5 is? Is 5th root a perfect one? It is, right? The 5th root of 32 is 2. And 2 to the 4th is? 2 squared is 4. Okay. Make sure you see how you can read it. Understand I'm saying the 5th root of 32, which is 2. Then I have 2 squared, which is 4. Yes, ma'am. Okay? You're doing all right? Anybody have an idea what that would become? First off, this is a power to a power situation, right? Does 8 have his very own power? It is. Remember, he is not connected to the x squared. That is the biggest thing people mix up, is thinking that 8 is squared as well. If it was, what would it look like? Parentheses around the 8 and the x, right? Does that make sense? Okay. Anybody help me on what you do to a power to a power? Multiply, so I go 1 times a third and 2 to a third. Can I simplify either of those? Can I simplify this, gentleman? What is 8 to the third? 2. Okay? Can I simplify anything within the right, you guys' left side, right? Left side. Anything in there can be simplified? I don't see any. You guys see any? I guess I could put him downstairs, but I'm going to just keep him right there just for a moment. I usually don't drop him upstairs or downstairs until I'm completely think I'm simplified. All right, what is this guy going to be, though? Power to a power. What do we do on power to a power? Multiply, right? So I have x to the negative 2/3 and power to power. How do we multiply fractions? Straight across. Which that comes out to be 6, which is 1/3. Does everybody see how I got y to the 1/3? Okay. What do I do with like bases when I'm multiplying? I add them. What's negative 2/3 plus 2/3? 0. What's anything raised to the 0 power? 1. If I didn't tell you that, you might want to know. Anything raised to the 0 power is 1. So therefore I have x to the 0, which is 1. With our y's, I have negative 1 plus a third. What is that going to be? I bet we could do that without the other common denominator. Does everybody see how it could be negative 2/3? Okay, do we like negative exponents? Yes, no? Sander? Do we like negative exponents? So where does it got to go? Jump the line! Change that sign! Yeah. Hi. The 2, what's the cube root? This says the cube root of 8. Cube root of 8 would be 2. You want me to break it down for you? Answer your question? Okay, cool. All right, here we go. This is a good one. That's a beastly one, huh? What do we want to do first? I, Mr. Roberts, would always order of operation this sucker. Order of operation says we need to do what? Anything inside the parentheses. Can we simplify stuff within the parentheses first? We can, because notice, see how we have multiple x's, multiple y's? Does everybody understand what I'm saying by that? So I'm going to go with that stuff first. Is there any other numbers besides 9? There isn't, so I'm just going to keep him on top. Okay. I have x on top, x to the 5, 6 on bottom. What's the power on x right now? 1. But once again, when they're on top and bottom, you need to subtract, correct? So I need a common denominator to subtract. So this is the same thing as 6, 6. Does everybody agree with 6, 6? So what's 6, 6 minus 5, 6? 1/6 on top or bottom? Top, and it should be on top because isn't there more of x on top than there is on bottom? You guys see how I'm judging how I know whether it stays top or bottom just by the fact of saying who has more. Correct? Okay. 4/3 minus a negative 2/3. What's 4/3 minus a negative 2/3? I need to write it over here. The minus minus becomes a plus, which is 2. Nobody's downstairs, is he? I guess you could put a 1 down there, right? Okay. Now I'm at my power to a power rule, right? What's my power on 1 even though he's not there? 1. So I have 1 times negative a half. That's 9 to the negative a half. Or x to the what? Negative a 12th. Everybody see where I got negative a 12th at? And y to the what power? 2 times negative a half would be negative 1. Am I done? Still pushing along singing my song, right? Okay, pushing along still. So every single one of those guys has a negative exponent, don't they? Whenever you have a negative exponent, they got to go downstairs. And what's the only thing I can reduce down there? What's 9 to the half? What is a half? Same thing as a square root. Square root of 9 is 3. I'm going to show you guys something really quick though. How many of you guys lose your negatives here and there? How many of you just looked on your test and maybe lost a negative and this and that? I do it all the time. Okay, so sometimes we get going and just an accidental loss here and there. Okay? So it can happen. So what I do sometimes, I'm going to bring this down. We were at one time, we were here, correct? Oh, this was, what was that? Was that raised to the 2? Okay. Anytime you guys have a negative exponent, all you have to do is flip the fraction on the inside. Because think about it. I'm going to make every one of those guys negative anyway, right? So where's that going to put us anyway? On the bottom. Does that make sense what I'm saying by that? So this is equivalent to 1 over 9 to the, oh, excuse me. 9x to the 1/6 y squared to the half. You ever see a negative exponent on the outside of something? Just flip the inside fraction. Then I bring it in. What's 1 raised to any power? 1, isn't it? Then I have 1 over 9 to the half, x to the 12th, and y, and I just say that once again is 3. Right? Yes, ma'am. Because once again, this was 9 to the 1/2. So if we go back from exponential to radical, remember that is the square root of 9 to the 1st, which is just 9. Answer your question. How are we doing there? Yes, no? Okay. We got probably 4 more examples. I know we have a lot today, but it's just giving you different types of them, right? Okay. How about this guy? I want to simplify him to be just 1x. How can I make him right now? Right now it's not very easy to do so, right? Do you guys know if they're both the same cube root, I could just divide that really easily? If this was, for example, the 4th root of x over the 4th root of x squared, that's 1 over the 4th root of x. If they're the same radical, I can just divide within them. Does that make sense what I'm saying? But are these guys the same radical? They're not. So, what can I write him as? X to the what power? 1/2. Does everybody see 1/2? Power of 1 here. That's a 2 right there, right? How about this guy with the bottom? 2/3. Now, does that become something I can do reasonably? Because what do I do when I go ahead and have division of like bases? Subtract them, right? But they're fractions, so I need to subtract them via how? I need to subtract them with a common denominator. Where does 1/2 and 2/3 meet up? They can be both base 6, can't they? So 1/2 is the same thing as 3/6. This is the same thing as 4/6. Rachel, what do I do when I divide like bases? Subtract it, so I get 3/6 minus 4/6, which is, okay. Am I done there yet? What's left? 1 over x to the 1/6. Yes, ready? Okay. Anybody need this still? Right. Okay. I'm going to start with something really quickly. I believe you guys have the capabilities of doing so. Let me start off just so you guys get the idea. Are you a cheerleader or just bought from a cheerleader? Have somebody's backpack in mind. Okay, x to the 4th minus x cubed. Can I add those two together? Why not? Because they're not like terms, correct? They're not both x to the 4th or not both x to the 3rd. But how many of you guys remember the word factor? Factor means what they have in common. What do those guys have in common? X to the what power? Don't they both have x to the 3rd in them? Notice that this right here is x, 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 x. You guys agree with that? What's this guy? What do they share? X to the third. You guys see how they both share x to the third? So if I pull out x cubed, what's left over? What's left over with this guy? An x. What's left over with this guy? Nothing's there, but there is something there. Because isn't everything times by 1? So there's a 1 left over. So what's a good rule of thumb when I factor out? What did I do to my exponents? Notice they shared the 3. I went from 4 to 1. What did I do when I factored it out? Like dividing it out, isn't it? And when I divide things out, isn't that subtraction? Right? You guys agree with that? Okay. And the reason why I showed you this one, let's go ahead and do one more. What if I had x to the 8 minus 3x squared? What do they share? If you share an x squared, that's what Ben says in the back. Ben, tell me what's left over? Minus 3. Right? So when I pull something out, I'm dividing it out. Okay. I'm going to show you one more quick right here before I get on to my example. If I had this, what do they share? They share a 3x plus 5. Does everybody see the 3x plus 5? Okay, we're going to factor him out. What's left over? The 4 doesn't come out, does he? So he stays there. I pulled one of those out of 2, so still one of them's there, correct? You guys agree with that? I pulled it out of there, but that 3 is still there, correct? Could I simplify that more on the inside if I needed to? I'm actually okay with that, but a different way to write it. So here comes the one that's a little tricky. Okay? You guys write that down real quick. If by chance I don't get time to give you guys your homework, I will put the homework online, meaning I'll tell you the problem. Does that make sense? No? So it'll be out of 7.1 and 7.2. I'll just tell you the specific problems out of that. Is everybody good with that? You know where my website is? djroberts.weebly.com. Okay? Where you need to search. I'll also put it on Skyward. If you click on this side, it'll tell you what problems you do as well. Okay? Fair deal? Yes, yes? Okay. All right, here we go. This is hopefully our last example. Let's see how you guys do with it, and then that will determine how we go. Oh, that's not one I want to do. Okay, we can start with an easy one first. What can I factor out? What do they both have in common? First off, I can look at the numbers. 6 and 3 both have a what in common? A 3. Does everybody understand how I can pull out a 3? Yes, no? Does anybody else share anything? Does either of those binomials look kind of same? X minus 5, but to what power do I get to pull out? You always go with the lesser one. Who's smaller, a half or 3 halves? 1 half, right? Sorry, I said. Okay, that's what I'm going to be pulling out. So if you'll notice, ladies and gentlemen, here's the first one. I pulled out that amount right there. So what's left over? Does everybody see the 3x plus 1 there, right? In parentheses. Okay? Now remember, when I factor out, that's like dividing. And when we divide things, we subtract, don't we? Right? You guys agree with that's what I said last time? So notice, first off, I pulled out a 3 out of a 6. So what is that first off? That's just plain dividing. I need to have a 2 there. You guys agree? Because pulling a 3 out of a 6 needs to be a 2. Okay, but I'm pulling a half out of 3 halves. How much is left over? 2 halves, which is a whole. This is x minus 5. So the inside here, we can make it look a little nicer. 3x plus 1 plus 2x minus 10. Or we could say our final answer is 3x minus 5 to the half, 5x minus 9. The key thing there, ladies and gentlemen, when you factor something out, especially with exponents, we are subtracting the exponents when I factor it out. Okay, that was a nice one. I'm going to pull out another one. Anybody still need? Go ahead and hold there for a second. I have no idea, man. I always lose the damn time. Like 9:07 or something like that. Is that what it is? Okay. I got 3 minutes. Right? So 4 minutes. I feel great, actually. Good times. Okay, here we go. This is our last one. No, they don't. Because they're not the same exponent, are they? One's a half, one's a negative a half. So which one am I going to pull out, ladies and gentlemen? They are the same, so Jamie brought it up. X plus 3 is what's going to be pulled out. Do you guys agree? Okay, to what power, though? Always do the smallest amount. Negative a half, correct? Okay, now when I pull out, it's like subtracting. Remember, as Ben did x to the 8th minus x to the 2nd, he pulled out x squared. How did he get x to the 6th? He went 8 minus 2, correct? You see why I showed you this problem? You get the general idea. We're pulling out negative a half. So I'm going to take a half, and I'm going to subtract a negative a half. A half subtract a negative a half, isn't that a half plus a half? So what is that? 1. So I still have that 4 there. X plus 3 to the first. Notice that guy got factored out, didn't he? What's left over on this side? The 2x plus 1, right? Then we simplify. That's 4x plus 12 plus 2x plus 1, which is 6x plus 13. That's the hardest part you got to remember. When you factor things out, you are subtracting something out. Okay? So one more time. Notice 1/2 minus a half becomes 1, right? Because that's a half plus a half. And then he's already gone just because that's who we took out in general, right? Okay, I think I might have time to get your homework out too. In your book, I usually just say the section. I think you guys can find the homework within the section. Does that make sense? So you're going to be doing 7-1. If you want to know, it's page 540. 7-1. 9, 15, 25, just randomly picking some, 49, I like 36, I'm going to put 36 right here, sorry about that, 55, 63, 67, 85, 91, that'll be good there. 7-2, which is page 547 if you want to know. Number 7 and 9. 17, 21. I'm just ready to get it done really quick, sorry. 35, 41, 47, 53. Okay? Thank you guys. Once again, if you guys do not know, your answers are in here to the odds in the back of the book. Bob is your friend. Backup book. Every odd answer is there. So you do have answers for them, okay? That's why I only assign odds. Yep. This number right here, 53. 53. Is that what you were wondering?
Take off half points on my quiz when I'm waiting.
Not half points, 5. But I don't do that in this one. Jacob, okay, Val, how you doing? Yeah. Is it true? Like, I swear I got a hot. No. Hey, buddy, how are you? Gracie? How are you? I'm still recording this dumb lesson. Good. Yeah. No.